machines, that is the universal lathe. Now the main components of the universal lathe are headstock, tailstock. Now this is the headstock assembly. This complete is the headstock assembly. This area it is known as tailstock. This end it is known as live center or rotating center, live center, CENTER, live center or revolving center, live center or revolving center, and this end it is known as dead center, as already mentioned here. We have the motor, very powerful motor inside the headstock assembly, and on which, on a spindle, this chuck is mounted. This region is known as chuck. This mechanism it is chuck. It has 3 or 4 arms, in which when we open by using a key, we use a key similar to like this shape. We put it here and we turn it anti-clockwise to release the chuck, and we put the workpiece here like this, and then again we put this key in this hole and we turn it clockwise, so the arms they will grip the workpiece like this, and now we can machine. Now this is the first operation, that is the mounting on the chuck, mounting of a workpiece on a chuck. Now we have a feed selector switch here, by which we can select the feed, how much feed that need to be provided. We have a spindle selector, spindle speed selector, that is what is the RPM that we require of machining, that is by which RPM this chuck along with the workpiece will rotate. We can select by using this switch. And we have a clutch here to engage or disengage, just as in automobile. When we apply the clutch, then no machining will occur, and when we release the clutch, machining will occur. Now this pan, it collects the chip falling from the machining, and we can periodically clean. This is known as chip pan. This complete lower portion, it is known as lathe bed, and it is made up of cast iron. It is made up of cast iron. Now cast iron, we choose cast iron because cast iron is brittle and it has good damping and vibration absorbing capacity, and it is also very strong. Now next comes the apron. Now we have this main portion of the lathe machine. This is the main portion, very important portion. Now you have to understand in detail. Now this portion, front portion, it is known as apron. This front portion, it is known as apron. This portion, it is known as cross slide. This portion, it is known as compound rest, and this portion it is known as tool post. Now from tool post you can understand a post where tool rests. We fix the tool here which do the machining. Now we use generally single point cutting tool. We fix on the tool post. On the cross slide is there if we have to do the transverse machining, that is we have to move the tool in this direction, not along the length but in the opposite direction, 90 degree. So we have this little knob. When we rotate it clockwise, so this cross slide, it moves the compound rest along with tool post in this direction, and when we turn this knob anti-clockwise direction, then this compound rest along with tool post, it moves in backward direction. Also the workpiece, it can be mounted between the two ends, that is if the workpiece is quite huge in length, so we need this extra support here. So the workpiece, it is mounted between the two centers, that is the live and dead center. So the maximum length of the workpiece that can be accommodated, it is the distance between both these centers. And if the workpiece is small, then we don't need to give the support from the dead center. Also this whole mechanism, this whole carriage, it can be moved in forward or backward direction in order to accommodate the length suppose length is this much, so we have to move in this direction. So we have a wheel, we turn it clockwise, this whole carriage, it will move in the forward direction. So now the tool will come somewhat here, and if we have the workpiece somewhat smaller, then we need to move this whole assembly closer to the workpiece. So we turn this wheel anti-clockwise direction, so it will move in this direction. We can adjust according to our length of the workpiece or dimension of the workpiece. And one other mechanism is there, that is known as thread cutting. That is when we need to do threading operation on a workpiece. That means we have to cut threads on a workpiece. Then we use this lead screw. This lead screw, it is employed, and by using the split nut mechanism, this is the split nut mechanism, we engage this split nut mechanism, and by using this lead screw we cut the threads on the workpiece. So I hope all the major points are covered, and if you have found the video helpful, please press the like button, please share my video on social media, and please subscribe if you have already not subscribed, and please check the description once for more of my social media links and other video links. I will see you in the next video. Till then, take care. Bye bye.
In this video, we will see about drilling machine, the construction and working of drilling machines. Drilling is an operation of making a circular hole by removing a volume of metal from the job by cutting tool called as drill. A drill is rotary and cutting tool which one or more cutting lips and usually one or more flutes for the passage of chips and the admission of cutting fluid. A drilling machine is a machine tool designed for drilling holes in metals. It is one of the most important and versatile machine tools in a workshop. Besides drilling round holes, many operations can be performed on drilling machines such as counter boring, counter sinking, honing, rimming, lapping, sanding, etc. Let's see the construction of machine and what are the parts required for making this machine. Base table is a heavy casting and it supports the whole assembly. Column is a vertical round or box section which rests on the base and support the head and the table. The round column may have the rack teeth cut on it so that the table can be raised or lowered depending upon the workpiece requirement. This nut and bolt is used for fixing the height for mass production. This handle gives feed to the drill. The feed is along the axis of the drill, that is up and down. Drill bit and drill chuck is held at the end of the spindle. Spindle is made up of alloy steel. It rotates as well as moves up and down in a sleeve. One end of spindle is connected with the pulleys and other is connected with the chuck. A pinion engages a rack fixed on a sleeve to provide vertical up and down motion of the spindle and hence the drill so that the same can be fed into a workpiece or withdrawn from it while drilling. When we rotate this handle, because of pinion and rack mechanism, the sleeve moves up and down. Basically, one end of pinion shaft is connected with the spiral spring so that the vertical height can be measured or controlled. In drilling machine, the drill is rotated and fed along its axis of rotation in the stationary workpiece. The workpiece is held on table and it remains stationary. The head containing electric motor, V-pulleys and V-belt which transmit rotary motion to the drill spindle at a number of spindle speeds. Spindle speed or the drill speed is changed with help of V-belt and V-step pulleys. Larger drilling machines are having a gearbox for the same purpose. Let's see the working of drilling machine. I have already mentioned that when we rotate handle, it will rotate the drill bit along its axis of rotation, that is upward and downward. The rotary motion of the motor transmitted to the spindle by using V-belt and V-pulleys. Vertical feed is applied using handle.
Hi, this is John on behalf of Expert Village. In this video clip, I will be talking about the parts of a random orbit sander. First off, in the front of the sander, we have our on-off button. At the base of our sander, we have our sanding pad. This is what we're going to put a piece of sandpaper on, which is going to allow us to sand our part. Next, we have our dust collection bag. As you're sanding, most of the dust is going to be pushed into this bag. If you remove our dust collection bag, this is what's underneath. It is our vacuum adapter. If you have a vacuum, you can hook it right up to there and it'll suck out all the dust. And lastly, we have the cord. The cord is the lifeline of your tool, so you want to make sure and protect it.
Power sanders can be real time savers on your projects if you use them right. When you're using any power sander, two things to avoid are underdoing it, that can take you forever to finish, and overdoing it, you can ruin your project. A belt sander spins these looped sheets of sandpaper like tank treads. It's a powerful tool, so it's best for rough work, and you need to know what you're doing. To install the sandpaper belt, you'll unlock the tension between these two wheels. Flip the tension lever, or on a spring-loaded model, push the front roller against your work surface. Slip the new belt on with the arrows pointed in the direction of the spin, and flip the release to put the tension back on the belt. Turn it on to see if the belt rubs or slips. If it does, adjust the tracking knob to keep the belt centered. The sanding action is linear, so you want to move in line with the grain and keep the sander moving at an even, smooth pace. Don't press down on the sander, let it do the work. Move in a zigzag motion. Let the sander go past the edge of the piece and overlap your next pass slightly. When you've got a narrow edge to smooth with a wide belt, be careful to stay level. Or if you have several edges, you can do what's called gang sanding. Clamp the boards together and sand all the edges at once. The belt sander works so quickly you can really make a mess of your project if you're not careful. If your sander has a variable speed, dial it down for delicate work. Take care not to round off the edge of your piece by tilting the sander. It helps to use a scrap of wood as a stop at the edge of your project. Gouges happen when the belt or sandpaper gets gummed up with dust, grit, pitch from the wood, and glue. Use clean belts and avoid sandpaper grits finer than 120. Keep the sander moving at all times so you don't sand in a depression. And keep it even on the surface so you don't create dips, bowls, or other imperfections. The belt sander is great for rough work, but it can be hard to get the hang of. So I wouldn't recommend it for beginners. For most DIYers, it isn't essential unless you find yourself with a lot of these types of tasks. Removing old paint, varnish, or stain can be time-consuming with a less powerful sander. You'd also use it for sanding large projects like solid doors or tabletops. But when you're using one to sand plywood and veneered boards, it's really easy to overdo it and ruin the surface. The belt sander would be your choice for that first pass on a really rough surface. You can also use it to even out cupped boards, or to take down a saw cut to your scribed mark. Here are some more helpful tips. Always wear eye protection, hearing protection, and a dust mask. Unplug the tool before changing the pads or emptying the dust collector so you don't hit the trigger accidentally. Check the trigger to be sure it's off before plugging it in, and never rest the sander on your project. For the tips, advice, and tools you need, visit your neighborhood Ace and find us online at acehardware.com.
Ace is the place with the helpful hardware, folks.